Good morning. You are a lot of people. It's kind of scary. So I want to talk about my project Deno. And I always have to give a bit of a disclaimer when I talk about this, because this project is experimental, and I think, a lot of developers might feel confused by this, and because Deno is a piece of software that acts very much like Node and solves a very similar problem. And I would just say that this talk is geared towards the more enthusiastic people among you, people who are, interested in kind of experimenting with how software could be different, especially in this realm of Node software. So I would just say that if you're a new developer, don't panic. Use Node. Node is going to be around forever, and just go get a coffee. So, like I said, Deno is a new command line runtime. It's a new code base. It's probably 8 months old, maybe even a year old at this point. And just to orient you in the world of software, this is primarily built on top of V8. V8 is the JavaScript runtime inside of Chrome, which is the same VM that Node uses. Deno is written in Rust instead of C++. And instead of libuv, again, this is going to be a bit technical, but if you know what libuv is, the corresponding element in Deno is a library called Tokyo. And it uses the TypeScript compiler. TypeScript compiler is actually built into it. So these 4 pieces of software in some way define the project. So naturally, your question is why? Why would you do this? Node is a thing, and it works, and isn't it working well? And yeah, it is working well, and it's a successful piece of software, and many people are using it. But when Node was designed in 2009, JavaScript was very different. We didn't have a lot of the conveniences that you have today. The language has changed quite a bit. So yeah, in particular, there weren't typed arrays back then. Like JavaScript only had strings. And so, trying to do TCP sockets with just strings is kind of wild. There's a new module system in JavaScript. By the way, I have to gauge your interest and knowledge here. So do you know what ES modules are? Okay, good. It's bad when you just get blank stares. I'm like, okay. Yeah, so there's ES modules now. This is a fairly radical change to JavaScript, right? So you have these import statements instead of require, and modules are statically resolved as opposed to dynamically resolved. So quite a big change. And of course, there's the async-await stuff, which makes non-blocking programming completely tractable. So you don't have to have callbacks everywhere and indent your code. You can do async-await. You know what async-await is? Yes. Okay. Good. Yeah, so I think that these things are killer features. So great. And Node would just look very, very different if these things had existed in 2009. Yeah, I think Node solves some problems, but I think it also has some of its own problems. In particular, the module system. So this whole require thing and this node modules, your node modules folder, this was an afternoon, and where should we put the modules? Let's put in node modules, I guess. there, it was an afterthought. The core design element of Node was based around this idea of doing non-blocking I/O. So it was, essentially a web server, a programmable web server. And originally did not have a module system. And essentially these things were tacked on as they were needed by users. And I think the resulting product, the resulting software kind of displays that lack of design. Yeah, I mean, in particular, we have NPM, which works and is great, but it's a centralized repository, right? There's a specific server that you go to get NPM modules, and this is not very webby, right? The web is about decentralization, and yeah, another aspect of this is that the V8 VM, of course, is a secure sandbox, right? Until you start poking holes into it, supposedly it can execute secure code, execute user code in a secure way, I should say. And when you run a Node program, like you have no idea of security anymore, right? Like anybody could access your SSH keys, right? There's no permissions. Like when you run something in a web browser, that's somehow secure, right? Nobody can access your SSH keys. So it's kind of regretful that well, I should say, this is not a problem just of Node. I mean, Python has the same problem. If Python can also, any Python program can also access your SSH keys, right? The problem, the thing is that Node could have been secure, right? Had we been more careful when we poked holes for TCP sockets and poked a hole for file system access, we could have maintained the sandbox in some way. Yeah, so it would be a very nice feature to have. And I think in general, I myself basically spend my professional life in C++ and Rust and Go and kind of statically compiled languages. And I think some people might ask, why isn't the time of dynamic languages kind of over? Like, aren't we moving to compiling everything into WASM and binaries? And I disagree with that idea. I think that definitely Rust and Go have made low-level systems programming much more accessible to people. But at the end of the day, I mean, I still am writing a lot of scripting, right? I script all the time, right? Maybe I need to maybe I have a directory of files and I need to rename a bunch of things, or maybe I have a big database and I need to kind of massage that data in some way. I'm not going to write a Rust program to do. I'm not going to bust out C++ to do this. This is something that that you would want to do in a scripting language, and I just think that these scripting languages are so useful and so important that it, yeah, I think it's worth trying to get this right. So yeah, essentially this project is just trying to make my own personal workflow the way that I want it for dynamic languages. When I was growing up, I learned Perl for the first time. And after having studied C in college, and it was just it was mind-opening to me, because it's just oh my God, I can do so much with this. It's have you had this experience? When you first really wrap your head around your first dynamic language, it feels very empowering. Yeah. I think it's important to get this right. So in some ways, I'm trying to build my Perl that I can use. So Deno is attempting to correct some of these mistakes. So it's breaking compatibility with Node. So no, you cannot run your Node programs in Deno. And no, I'm not going to try to make that work. This is kind of the benefit of choosing a new name and going in a different direction. Node is a very stable piece of software at this point, and that's a good thing. Like, you know, there's committees to decide on API changes, and you want that in a big, stable piece of software. But to be compatible with Node would be very difficult and would mean making compromises. And since this is an experimental project, I mean, what the hell? Let's just be experimental, right? So it's very new JavaScript. So it only uses ES modules, and it does not use npm. There's no package manager at all. In fact, there's only a URLs that you can import. So have you gone into the web browser and tried to like import from a URL yet? Possibly. Like this works these days, right? Like you can, the ES modules work in web browsers. So essentially the Deno module system, the Deno package manager is URLs. And I'll demonstrate this. And Deno is trying to be secure by default. And I'll show you what that means, hopefully. And yeah, Deno tries to be browser compatible. So yeah, like originally Node, for example, when you print to the console, right? Console log. Originally, this was just called print. Like I didn't know anything about web browsers, so I was just kind of defining functions left and right. And at some point, somebody came up to me and they're like, "Why do you call it print? Why not console log?" And I was like, that's a good point. The point is that Node did not have the goal of being completely browser compatible, and it's an important thing to kind of set out to do from the start. Yeah, so let me just open a terminal and play around with this and give you an idea of what the hell I'm talking about. So can you guys see that? Is that visible? Okay. So I'm just going to make a new directory here. Right. So here's Deno. And right, when you execute it without any command line arguments, you get a REPL, much like Node. By the way, I mean, if you're looking for something amazing happening here, you're going to be sad because these are going to be very normal sort of things that you can do in Node. But hopefully I can convince you why this might be interesting. So if you do -h, if you look at the help, you see all these options here that are like, oh, allow read, allow write, allow net. And you're like, what's this about? So this I'll get to a bit more, but this is essentially the permissions that allow you to opt out of the sandbox. And Deno has TypeScript built in, as I mentioned, so it can run JavaScript and does fine. But I very much like TypeScript. I think Microsoft has done a fantastic job with it, and I think it's, you know, I'm convinced that TypeScript is essentially like the next version of JavaScript. So anyway, what's something nice that we can do is Deno --types, and we can tell you exactly what the runtime provides. So if you do this, it prints out all this stuff, and you're like, what is that? So I'm going to pipe it into Vim, and then I'm going to set my file type to TypeScript. Okay, and so this is a declaration file that kind of defines what is in Deno. And so you see there's a Deno namespace, and there's deno.pid. So maybe if I open another terminal here next to it, we can examine this a little bit. So like deno.pid will give you the PID, right? So there's this capital Deno object. It's a global variable, and it's essentially a flat namespace that kind of contains all the native functionality that you would want. Okay. So in Node you might do require net, require fs. All of that stuff is basically packed into this thing, and it's a flat namespace because I essentially know what I'm going to be exporting from this, and it's essentially a POSIX sort of API. So maybe you're looking through here and you might find something like open, which is what would you expect open to do? Oh, it opens a file, of course, right? So yeah, everything inside of Deno is defined in this declaration file, including things like webby sort of things. Console object is here, I guess. Yeah. Okay. So anyway, quit out of that. And yeah, let's write a little program here. So I'm going to write, just as an example, like cat, like the Unix cat program. So it takes a file name as an argument and prints it to standard out, right? So what does that look like? So let's just start with Deno. I always like to start with some console logging, some console log action. Makes everything sane. So let's just print the arguments. That's the command line arguments. So I'm going to run cat.js, and I'm going to try to print out EDC password. Okay, so that's printed the arguments. You guys can see what I'm typing, right? Yeah. Okay. One guy can. Great. So let's pull out the first argument here. Let's say let file name equal that. And what are we going to do? Let's open this file, right? So let's deno.open file name. And of course, Deno is non-blocking I/O, of course. And so this guy is something that accesses the disk and thus returns a promise. And so we need to await the result here. We don't support top-level await yet, unfortunately. I would like to at some point. So we need to wrap this whole thing in an async function. So I'm just going to write like main and an async function and put this guy up here. And then I'm going to do like that. Does that look good? And let's just log this file object and see what it looks like. Oh, didn't do anything. All right, I have to actually call main here. OK. So the first interesting bit is that it's like Deno requests read access to EDC password. Do you want to grant this? So as I said before, like Deno has this secure sandbox by default, and obviously you don't want to allow people random scripts to cat your EDC password file. And so if I type a, allow always, it's going to succeed. If I ran that again and typed no, we're going to get a permission denied prompt. Okay. So yeah, let's run that. And note we get this file object out of there, and it has this RID thing. RID is essentially like a file descriptor, resource ID, although we don't call it file descriptors because it doesn't map exactly to file descriptors. But yeah, let me show you something interesting. So this idea of resources, in POSIX, right, in Unix, this file descriptors is a fundamental concept, right? It's an open file or a socket. And we have a very Unixy flavor here. And so resources are very central to Deno. And we have a way to examine those things. So I'm going to do console table Deno resources to print a table of the resources that are open right now. And maybe I'm going to do that before the open and after the open. So also, by the way, you can always opt out of this password prompt with the -a, right? OK, so check this out. So before this, these are the resources that are open, 0, 1, and 2, standard in, standard out, standard error. very Unixy, right? And after we've opened the file, you'll see that there's a new file descriptor number 3 here, right? And yeah, Deno has something like close, and you can close any file descriptor. So let me just try to close 3 and print that out again and see what happens. OK, so here's the first one, and here's the second one with the file open. And yes, we have closed it in the third one, right? OK, so anyway, a little deviation from what I was talking about. We were trying to write a cat program here, right? So what do we want to do? We want to print this to standard out. So you get standard out with deno.standardout. And the way that you can copy things, copy 2 streams. So standard out is a resource itself. And yeah, I would say I've thought quite a bit about this function. And this function, although I won't go into it in much detail, I think is optimal and is a 0 copy. And this is very much modeled after Go's standard library, if you're familiar with it. Any Go programmers in the building here? One guy. Oh, there's somebody. Great. Well, you two, this is all for you. Yeah. OK. So yeah, let's copy it to standard out. And this too is an async function. So let me put that in put in the await there. And ta-da! I have now printed standard out. OK. So just a little flavor of what Deno's doing. So yeah, I said before that it's kind of more webby than normal. So let me try example2.js. Do you guys know what file name does in Node? Yeah, OK, some people do. It's the current file that you're in, right? So this file was ex2 underscore file name. It drives me insane. Like, why did I choose this name? I don't know. Bad choice. File underscore file name does not exist in Deno. This will crash. I would never put that back in there. So the question is, how do you get the current file name? There's a very web standard-y way of doing this. Any brave person want to yell out what potentially that? How do you do this in the web browser? Oh, yeah. OK. I think somebody over here got it. I'm not sure what you said, but. Location. OK, yeah, let's try it. Location.href. OK, so yes, actually there's a location object, and yes, this is actually printing a file URL. There's also this weird thing called like import meta URL. Do you guys know that one? So those two things actually are the same things there. Yeah, let me import another file and let's examine this further. So I'm going to do ex2 foo.js. This is another file here, and I'm going to create a function foo, and I'm just going to print these 2 things in foo as well. And I'll prefix them with foo here, just so we can know what we're talking about. And I'll export this guy, and I'm going to import foo from /ex2 underscore foo.js. Yes, by the way, you must leave the file name extensions in there. This is exactly web compatible ES modules, right? So let me run this again. Oh, should have printed. Oh, I have to actually call foo here. OK, so yeah. So these are the guys from main that we saw before, the first 2 ones. And these are the guys from foo, right? And in foo, location.href, oops, don't know what that was. OK, in foo, location.href is this ex2.js, and the import meta URL is ex2 foo.js. So you were wrong, guy over there. It's not actually location. So location is the main file actually, and the import meta URL is the __ file name. And yeah, this is a random example, of course, but I'm trying to give you a flavor for what I mean by kind of browser compatible. We try very hard to make this something that could also potentially work in the web browser. Let's see. Oops, wrong way. Yeah, let me show you a little bit more interesting things. So let me try an echo server. So this is going to be a TCP server that you can cat stuff to, or you can send data to, and it's going to send back the same data, right? So how do we do this? So first of all, I'm going to pull out some guys from this Deno object. So remember this Deno global variable here. I'm going to pull out listen, and I'm going to pull, and I think that's all I need. And then I'm going to create my boilerplate, so annoying, function main, and blah, 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 okay. And then we'll do listen, and we do listen TCP, and let's choose port 8000. And so this will create a server, which I'll call S, right? And just to make sure that everything is working, let me just log that and see if that works. So Deno echo server JS. Oh, didn't do anything. Oh, got to actually call main here. Okay, so again, we get this prompt, Deno requests network access to listen. Should we grant that? Well, let's just say allow net. Okay. Okay, so we've got a new listener socket here, right? RID3. And what can we do with the server? We can accept a connection, right? So let's try this. Let socket equals this .accept, and accept, of course, is an asynchronous function, so we have to do it in await here. And let's just try to let's write something to the socket, right? So socket write. Oh, this brings up a point. So Deno works very much on the level of typed arrays, so uint8 arrays. So this sort of thing, writing a string to a socket, we don't handle this, not at all. We only deal with with typed arrays. So there's no implicit encoding. So actually, what I need to do here in order to write this message is I need to encode this message into a uint8 array. And I always forget how to do this. Is it text encoder? Decoder? Oh, man, you guys are worse than me. Okay. Encoder, encode. Let's try this. Hello. I think this creates a uint8 array. I am not sure. Of course, I should have tried this before I got up here on stage, right? So, okay. There's the hello object. Let's try it again. Oh yeah, it totally worked. Okay, so yeah, now let's connect to. Ooh, no, let's not do that. Let's try to connect to this server, and I'm just going to use netcat. So netcat localhost 8000. Oh, and I got hello, and then everything shut down. The whole server shut down, right? Okay, so let's improve this slightly. We'll do a while true loop here, and then we'll put that in there, blah blah blah. And let's use that same function that we used before, that copy function. So I'll just pull that out here at the top, copy, and let's copy socket. Okay, I think that should work. So there we go, we've started it, and we got something, and we can say blah, blah, blah. Oh, okay, it's sending back the same data to me, right? Oops. Yeah, I think we can connect again. Yep, seems to work. Okay, cool. So that's essentially what the TCP server does. In Node, the HTTP server is built into Node. In Deno, we have what I consider to be a quite nice module system. Oh, I'm going quite slow. I have to speed up here. HTTP Server.js. Oh, let's switch to TypeScript. Although it's a bit difficult to do TypeScript in a live audience, right? I mean, the whole point of this kind of JavaScript TypeScript world is that you can prototype and you can hack very fast in JavaScript, right? This is great, and slowly over time you can kind of build. If your hacking kind of turns into something that you want to reuse, then you can slowly start adding types to it. So this kind of optional typing model of programming, I think, is great for dynamic languages, right? You often start with a prototype that slowly migrates into something that needs to be more robust. Anyway, so here's how we do our HTTP server. It's an external module, so we're going to import serve from the HTTP module, which is hosted at Deno Standard HTTP Server.ts. Okay, and again, have to write my boilerplate. I can't wait for top level await. Oh, it's going to be so nice. Okay. And let's just do serve, and I think we can just give a port 8000, and I think that's going to give me a server, and I'm going to console log that guy and see if it works. Okay, kill that. Let's try this again, not with Echo Server, but with HTTP Server. Okay, so we got this weird message here, downloading something. So Deno can download and fetch modules itself. So it does act as its own package manager. And yeah, let me complete this example, and let's try to examine this a little bit more. So for await, this is how the web server looks in Deno. So you await a request with this for await loop. And I can console log got a request. And let's see if that works. Okay, running for let request of. Oh, yes. Okay, it hasn't printed anything. Let's curl localhost 8000. Okay, got a request. And if I cancel that, got another request. Got another request. Just for the sake of completion, let's create that hello message again. New text encoder dot encode hello new line blah. And again, we only work on the level of typed arrays. So. And then we do request, respond, and we can give a body, which is this hello object. Let's try that. Again, I'll give this -a because I don't want to mess with that. And we got hello response. Okay, so that works. So right, so this web server, as I mentioned, is not part of Deno built in, right? It's kind of part of this third-party module system. And well, we can examine this a little bit closer by doing deno-info. So when you do this, it kind of prints some information about the program that you're currently running. So it's a TypeScript program. It's located here. Here's the compiled JS form, which is in this weird directory here. Maybe we should check that out. So there's this cache directory, and yeah, what's in this guy? There's like a deps folder and there's a gen folder. If we look in the gen folder, you'll see all these compiled assets, source maps and JavaScript. And in the deps folder, you'll see HTTPS, and you'll see raw GitHub user content and Deno and Deno Standard. Yeah, so this is the
the cache where it downloads stuff to. And you might feel a little weird about this. Like, how can you rely on, what if you're on an airplane? This isn't going to work. Like, how is this supposed to solve your module problems? Like, you can't rely on the internet being there all the time. And I would say, I think this is completely a solvable problem. In particular, you can take this cache directory and you can, for example, check it into a Git repo. And then you can set an environmental variable called Deno-dir, this guy. And then it will always resolve from that directory, right? And so in that way, like, you don't need to rely, although you're still referencing URLs, they're cached, and they're cached because you've sent this environmental variable. So I think this is quite like a nice little module system. Yeah. So I kind of need to skip a bit here, but I would say Deno is organized in a bit more organized way than Node is. It's much more like a operating system, right? So we don't trust user code. So these are kind of like processes, right? And we have web workers, and so you can kind of run different processes here. And we have this idea of ops, which are essentially syscalls, ways to break out of the VM. And all calls in Deno, all things that exit the VM, are organized as an op. And ops send back and forth array buffers, uint8 arrays specifically. And along with ops, you have file descriptors, which kind of talk about a resource that is allocated outside is managed outside of the VM. So something like a socket, but there's other things too. And yeah. Well, I think you can kind of summarize it with this drawing, which is an extremely simplified way of presenting this. But essentially, we're just sending uint8 arrays back and forth, okay? And so people who implement kind of functionality inside of Deno, in kind of the Rust side of Deno, native functionality, they don't get to have access to V8 handles themselves. They're sending back and forth typed arrays. And yeah, that's very oversimplified, and this diagram actually is way oversimplified too. But it's a bit more complicated than that. But essentially, the design philosophy here is that all things should be ops, and all things should be sending typed arrays. Okay, and I think this is quite a nice way of organizing a VM. So I think there's use cases. I think JavaScript is extremely useful. Dynamic languages are extremely useful, and JavaScript in particular is kind of the best of these. Yeah, I think there's use cases for this where a browser is not appropriate, and also like Node/Deno is also not appropriate. There's kind of like this in-between use case. So for example, imagine you're implementing a new database, right? And imagine that you want to have a MapReduce function, and you want to give your users the ability to send some JavaScript to this database to do a MapReduce, right? Or imagine you're doing some sort of serverless type system where you want to give, you have essentially a web server. Think Cloudflare workers or Lambda at Edge. But you want to kind of present an easy interface to kind of scripting this web server, right? Shelling out to Node, it's kind of inappropriate. And this is largely what people do to solve these problems. Node has all these security concerns, so now you have to run it in a Docker container, and you're going to have all these files. You need to have npm installed. You need to have some way of like potentially installing modules. At the other end of kind of the spectrum is like raw V8. Like why not just use raw V8? Well, raw V8 is very difficult. It's essentially not approachable to many people. And I think that there's a middle ground here. And with the design of Deno, we're trying to address this by kind of having this tiered architecture where we have a lower level API, which is published as a Rust crate. And yeah, this API doesn't include a lot of the stuff that I just showed. There's no command line utility. So essentially, all this gives you, this crate, is a way to send typed arrays back and forth from V8. Like everything else is up to you. You have to do everything else. But it does kind of the heavy lifting part of mapping promises in JavaScript to futures in Rust. And futures is essentially the promise analog in Rust. So it's saying an FFI would be too strong because it's not that automatic. But essentially, you can program this correspondence between defined promises in JavaScript and things in Rust. And you do it by implementing this crazy callback here, which is Rust, so probably not intelligible to you. And even if you know Rust, it's not going to be intelligible because it has all these types that you don't know. We're working on this interface, and I think it's important to get this right. Like this is kind of on what everything sits on top of. Everything sits on top of these ops that send back and forth typed arrays. Yeah, there's a lot of problems that are trying to be solved here. One of the things is the user space, like this HTTP module that I showed you, lives in something called Deno Standard. It's a standard module set. We didn't have this with Node. All the standard modules are basically built into Node. And what this created was a situation where there's a lot of little utility modules in NPM that you end up kind of getting into this dependency hell situation where one person kind of wants this thing, but that depends on that one, and then and suddenly you have like 10,000 modules that you depend on. The idea with this is that if we have a standard set of modules and we kind of push everybody to put the common utilities into this standard location, that of course your dependency tree is going to fan out, but hopefully it terminates relatively quickly. Right? It doesn't keep spreading like this. So yeah, the core things that this provides is that essentially it's reviewed by me. So you can be somewhat confident that it doesn't have some hack in it, and it doesn't have external dependencies. So once you depend on something in Deno Standard, your dependency graph terminates. So this is one thing that tries to address the dependency hell problem. The other being kind of our use of this very simple module system, namely the URLs. I should talk about performance. So we measure, I'm very, I don't know, kind of a performance freak, I guess. This is kind of what I like to nerd out on. And so we track performance on every commit, and we're being very careful that we kind of push the project in the right direction over time. And so this is a graph of startup time. And so bigger is worse, smaller is better, right? And this is a graph over the course of a couple of months where we basically pushed a certain benchmark startup time from like 2 seconds, which is ridiculously bad, right? Down to, I don't know, 0.01 seconds. Turns out to be like 3x faster than Node. Who cares? Node starts up very fast anyway. The performance problem that we have not yet solved is kind of, I mentioned there's this ops model where everything kind of sits on top of this message passing interface. And so like this is the entire bottleneck for the entire system. This dispatch function, right? And that's good, because if we can make that fast, then like basically all of the ops become fast. And so we designed it in this way so that we kind of have this one place that we need to make fast. And currently it's not so fast. So this is a HTTP server benchmark where bigger is better. This is requests per second. And at the top here is this green guy is a pure Rust web server. So this is kind of the upper bound of what should be possible on this machine. Down here on this purple line is Deno's web server that I demoed earlier. Very bad. Well, I would say not very bad. It does thousands of requests per second. It's fine. But we're kind of not OK with that, because Node's web server is this blue line over here. And actually, let me zoom into the side here. So the thing that we're working on right now, and part of the reason I came here to this conference is to try to entice some of you guys who may be interested in these performance problems and coding in Rust to have a look at this, because I think these are fun problems to solve. So Deno's TCP server is this brown line here, and Node's is here, this pink line. So Node is a bit faster, right? Deno core itself, if you throw away all the command line utilities and you just implement a very basic TCP server on top of that Deno core module, that crate that I was showing you earlier, it's actually quite fast. It's up here, right? So what this tells us is that there's a performance gap. Like essentially, this brown line should be up here by this red line. There's some bottleneck in here, okay? And I'll just tell you, it's our serialization of the ops that get sent back and forth. We understand what is causing this, and so this is a performance gap that we need to close. And yeah, I would just say that these are fun problems to work on, because we track them very carefully. And so, if you can make the plot go in the right way, then you can be a hero, maybe, just for one day. Yeah. So, right, roadmap. So Deno, as I said, is an experimental piece of software. And this is, of course, a very ambitious project. And Node works. So all of you who are less than 5-year-old developers, ignore everything I've said. Go use Node. Don't worry about it, OK? It's going to be around forever. But yeah, I find this interesting, and I'm going to pursue this. It's getting a bit better. I used to give this talk and not demo anything, because it would crash every second. It's a bit better these days. So hopefully in the next couple months, maybe by the end of summer, we'll have something that I would consider calling 1.0. We have to deal with these I/O performance issues. We need to parallelize the code loading pipeline. When you import like an HTTP URL, you'll see a bunch of downloading things. It's quite ugly. We're going to clean this up. It'll be quite fast, like a web browser. We don't have SSL support yet. We have to do that. Yeah, and well, some other things. We've kind of built up this kind of base functionality, this new code base, which I think is kind of well designed in my humble opinion. And I think that now that we have this base and it's starting to become usable, we can start doing cool little one-off things. And I'm very interested in V8 snapshots, and I think there's cool things to do there. Yeah, talk to me if you're interested in such things. Eventually, someday, once all of these kind of basic issues are solved, WebGL is on the horizon. This is, I have some statistics homework to finish, and WebGL would allow me to do this. So yeah, but not yet. And yeah, Deno is not just myself. It's built by a number of people, in particular, Bert Belder, Kitz and Kelly, and Kevin. So it's an open collaboration, and I would yeah, welcome anybody who's interested in this sort of thing. And maybe I have some time for questions. Do I? Yeah.
You have.
Whew, that was a long rant.
First, thank you for the talk. It was really interesting. My question is about permission systems. For example, if I'm not doing microservices in Docker, in this case, the permission system is not so useful. For example, I'm doing a web server with a monolith that definitely would require file system permissions, web permissions, and all others. Then how can I be sure that some of the requirements of my requirements would not get my SSH folder? What is the reason? Well, you understand.
Yeah, I mean, you're going to have to, I mean, at this point, like what you would do is you would run your code and you'd kind of step through and not click accept all, but just kind of yes, 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 and you kind of get some idea of where the requests are coming from. The point is with this security system is not necessarily this this kind of prompt model that I showed you here, but just that we are aware of this and we're trying to maintain it. So I think in the future we could have kind of better utilities for inspecting where people jump out of the sandbox, and you know, better than these prompts here. But the point is that, you know, if you can jump out of the sandbox, we consider that a bug that needs to be fixed. So yeah.
But how can I defer my request to my config file and the molecules request to the my SSH folder? It's the same permission.
Say that again.
If I, for example, I'm starting my web server and I give it permission to read file system to read my config file, for example.
Yeah.
But after that, any
subsequent guys can access something else. So then they might access your SSH key.
Yes. So if I have at least middle-sized application, I would have all permissions on by default. And what is the meaning of having them in the first place?
That you have some inspectability rather than none. Yeah, of course, when you run it, you're going to have probably everything turned on because you kind of know what it's doing. But when you just start running things, especially when you just start running a program for the first time, and you know, by the way, like, let me show you something. So Deno HTTPS. So this is a little web server, standard HTTP file server .ts. So this is a little program that can browse your local, serves up your local directory, right? And when I run this, it's going to ask me for a prompt, and I'll say yes, and then it's going to ask me if it can accept things, and I'll say yes, and it's going to give me a URL that I can visit, and I'll try to curl that, and it's going to ask me again if it can accept the connection. You know, I'm clicking yes each time, and if it can read this file, and if it can read this file, and if it can read this file. The point is you have this very basic form of being able to step through your code and see these sort of things. I think in a future version, it would be nice to have like more robust permissions that aren't just binary, but you could like say, oh, I want to give it file system access to this subtree. This is, you know, essentially an easy feature on top of this more granular permission system. I'm going to just click all here, so I'm not randomly showing you something. Let's see, 27.0.0.1000. Oh, 4,500. Oh wait, let me do -all, run this program. So this serves up my local directory. And I guess the other thing I wanted to point out about this is that, like, Deno is kind of like a browser for scripts in a way. Like you don't need to download these programs. Like you can kind of go to them as URLs in itself. We do need more granular permissions. It would be nice to have like a whitelist for network connections to be able to say like, oh, I only want to allow access to google.com. These are essentially easy features on top of what we have now. Thanks.
Hi, Ryan. Very nice. I believe we witnessed something new, revolutionary. I mean, you are the creator of Node.js, so I believe it will be a successful project. I'm concerned about import statements. Are these can we use variables?
Nope, you can't. That's
Base
part of the
URL.
specification. So it's evaluated statically ahead of time. Right, so you're concerned about the case where, you know, oh, I read somebody's SSH key and then I kind of stick that into an import statement somehow, like question mark SSH key, and right?
Yeah. Well, I mean, a Node package manager is like Deno package manager. I think there should be something like this in the future.
I think there needs to be some ergonomics on top of this. We're working on kind of the base system, and making this ergonomic is a little bit, you know, essentially making aliases to some of these commands.
Okay, where do you see Deno against Node.js in, let's say, 5 years from now?
Oh, I can't answer that. This is a very experimental project. It is not at all clear that it would live beyond the year. So it seems interesting, but yeah, I don't know.
Right, thank you.
Do you see any real-world cases for Deno?
Yeah, sure. I mean, like I said, like this is trying to be my Perl. So this is what I want to be my main scripting language, right? I want it for, you know, renaming files, kind of one-off sort of things that you would do. But I also want it for all the situations where I would want a dynamic language inside of a larger system. So hence this Rust crate situation. Yeah, you know, if you're writing a database in Rust, like, please come talk to me. Like, we have things to discuss. So, yeah, I don't know. How many of you have tried Rust? It's very nice. It's super nice. Super hard, but very, very nice. Try it. It's an interesting language.
Hello?
Hello.
I'm here? No, I am here.
Oh, hello.
Hello. So my question is about Tokyo and how much it will differ from libuv. How much will it follow the same architecture, maybe design ideas, that thread pool, asynchronicity, and everything else? How will it differ, and or how what do you say, or how alike will it be?
So Tokyo is different in that it executes these features on many different threads. I think it's more similar to like the Linux kernel scheduler. It's much more of a scheduler than libuv, which is really based around a single event loop. And I didn't mention it in here, but the V8 isolates, sorry to get technical here, the V8 isolates are modeled in the crate as futures themselves. And so what's really nice is that because the V8 isolates are futures and they're running inside this Tokyo thread pool, they get kind of scheduled to different places, right? Whereas in Node, like you really allocate an entire thread to executing a single isolate. And so potentially this allows you to run more workers than you normally would. And also things like TLS, when we get to this, will be done in the Rust land, and so they can be done. Like TLS can be decoded asynchronously from the V8 runtime, and basically we can offload a lot of stuff to the thread pool. Whereas in libuv, the thread pool is much more just for like blocking file I/O.
Yeah, thank you. It was the last question. So, thank you. Ryan?
Thank you.
You can meet Ryan. You can meet Ryan at the